Hello and welcome once again to today's section. So today we'll be looking at energy, looking at the various forms of energy. Our focus is going to be on two main, the ones with the calculation. So we have different types of energy. Energy is also the ability to do work. But today we are going to focus on two main. We are going to focus on potential energy and kinetic energy. We are going to look at various calculations that you can do under these forms of energy. So now when we take potential energy, we all know that potential energy is the energy a body possesses when the body is not in motion. So a body which is not in motion, that is, the body is not moving, we call the energy that body possesses potential energy. Then we have another one, which is what? Kinetic energy. Kinetic energy is the energy a body possesses when the body is in motion. So anything that is moving possesses what we call the kinetic energy. So potential energy, a typical example is a parked vehicle, a table, a ball on a table, or a table at one place, like a trophy on a table. That the energy that object possesses is potential energy. But when an object is moving, typical example is a moving car or a body that is moving, a human being that is running, we have a ball that is rolling. The energy that object possesses is what we call kinetic energy. Now, these two forms of energy, we have formulas we use in calculating them. So when we take potential energy, which you can write as PE, the formula for calculating potential energy is your mass times your acceleration due to gravity times your height. So you need these two parameters to be able to calculate for your potential energy. Then when we come to our kinetic energy, we use the formula 1 over 2 times your mass times your velocity squared. So these are the two main formulas that you should always have in mind when you are calculating potential energy and kinetic energy. Now, a sum of these two energies, that's the potential energy plus the kinetic energy, gives us what we call the mechanical energy. So the mechanical energy is the sum total of the potential energy and the kinetic energy. We'll look at one example each for the two types of energy that we have here. So let's first start with potential energy. So the typical question you can be given: calculate the potential energy of a ball of mass 20 kilogram if the height of the ball is 5 centimeters. Take G to be 10 meter per second. Now, so with potential energy, anytime you have to calculate for potential energy, one thing that you should note is that you will be given your acceleration due to gravity. Now, your acceleration due to gravity will be given to you as 10 meter per second square, or sometimes it can also be given to you as 9.8. Now, when it's not given to you, preferably you can choose the 10, which will make your calculation easier for you. Or sometimes when it's given to you as 9.8 also, you can use any of them. So here we come and we write our parameters down. So here we have our mass, which is 20 kilogram. We have our height, which is 5 centimeters. Then we have our acceleration due to gravity, which is 10 meter per second. So we put them in our formula: mass times acceleration due to gravity times height. So here our mass is 20, our height is 10. Sorry, our acceleration due to gravity is 10, and then our height is what? 5. So here we have this times, this giving us 200 times 5. So 5 times 2, you give us 10, 1, 2. So this, and always your unit, which is in what? Joules. That's the unit for energy. You always leave your answer in joules. So here we are going to get 1,000 joules as the energy possessed by the ball which is on the table. Because the ball is not moving, the energy the ball possesses is 1,000 joules. So let's look at another example for kinetic energy. And after that, I'll give you one example for each so that you try it. So for kinetic energy, a typical example, calculate the kinetic energy of a train moving at a speed of, let's say, 12 meter per second if the mass of the train is 100 kilogram. So you have a question like this: calculate the kinetic energy of a moving train. Let me make it a moving train. So, of a train moving at a speed of 12 meter per second if the mass of the train is 100 kilograms. So here we come to our solution. The parameters that we have the speed, which is the same as the velocity, to be 12. We have our mass to be what? 100. Then we are finding our kinetic energy. So kinetic energy, which we all know, the formula is 1/2 times mass times velocity squared. So kinetic energy 1/2. Our mass here is what? 100. Our velocity is what? 12 squared. So 2 cancels this, gives us 50. Our kinetic energy becomes 50 times 12 gives us 144. So you multiply 144 by 50, 0, 0, 0, 5, 4, 20, 5, 4, 20, plus 2, 5, 1, 5, 7, 7, 2, 0, 0. So our kinetic energy becomes 7,200 joules, which becomes our kinetic energy. So it means that the energy the train is moving with is 7,200 joules. So I'm going to give you 2 examples, one for kinetic energy and one for potential energy, so that you can also try your hands on it. So you try your hands and then you leave the answer in the comment section. So calculate the potential energy of the table. So you are taking the G to be 10 meter per second. Then a second question: a bullet is shot from a gun at the speed of 10 if the mass of the bullet is 80 kilogram. Calculate the kinetic energy of the bullet. So these are 2 typical questions I want you to try. One on potential energy, one on kinetic energy. So you leave your answer in the comment section. Thank you, and I'll see you in our next video.